So this talk is going to be about Mongo 3.4, specifically Percona Server and Mongo Community 3.4, and what's new in it. It's a pretty quick talk. It's a 25-minute talk, so I'm going to get into it. Real quick, who am I? Actually, agenda first. So I'm going to talk about who I am, and then what the basic types of softwares are in the ecosystem. I went into a little more depth in the last talk, but this one I'll quickly talk about them. And then what did we have up until 3.2, just as a high level? What are some of the big things that we had up to that point? And then what are things that we are new or improved? And then a little bit on understanding the big differences between Percona Server and this Enterprise. So I am David Murphy. I am the MongoDB practice manager for Percona, which means I touch everything from roadmaps to support to consulting inside of Percona. And before that, I worked at Electronic Arts as the NoSQL MySQL architect for a while. And as well, I was one of the original hires at Object Rocket towards their MongoDB platform. And that was a very interesting and growth experience as it was exploding from startup to a very stable infrastructure that you can still get on today. It's a really great product. I'm still friends with all the DBAs that I helped train up there. Some of which I brought over from EA. I'm also a Mongo Master alumni, and that means that I was very early in the Mongo ecosystem. I was established as an expert in the area. I know a lot about it. I do core code contributions. I write patches and plugins and test for Percona Server as well. So I'm very engineering in. I'm not just like a business person saying all the cool stuff. I very much am passionate about fixing the problems that are annoying me as much as the community. And I've been using Mongo since 1.6. So the main softwares in the ecosystem are Mongo Community. So this is the one that has all your base features, your WireTiger, your mmap, all your main aggregations and query options and sharding and all of this stuff, the very base nuts and bolts that most people are using. And then you have Mongo Enterprise Advanced, which adds a lot of security features such as LDAP, auditing, encryption, stuff like that to the mix. And what we've done is over the last couple of years, we've been building Percona Server for MongoDB. We're now at version 3.4. So we really release that usually a quarter or so after the main ones, and once it's nice and stable. And we can certify that we think it's going to be stable for you to use. And in ours, we've provided LDAP and auditing and a lot of those features that are necessary to get PCI compliance, or when you're looking for just improved ways or additional choices with storage engines. And we are always eliciting feedback from the community on additional features that you might need or problems that you need solved. And we look at what we can do there. Another one was TokuMX. And so last year when you were here, actually was that last year? No, not last year, the year before last, when you were here, and we announced that we acquired TokuTech. We also acquired TokuMX at that time. We have since killed this product because it is a complete fork from Mongo. So think about it like the MySQL and Maria drift from Mongo 2.2. We're now on version 3.4. It's quite a big drift on those. And I couldn't pull that back together easily. So we end-of-lifed that product to focus on the main Mongo ecosystem. So just be aware that had some very interesting features that unfortunately we lost when we needed to kill it, such as partitioned collections and it uses a fractal tree, and it was very efficient, very fast at writing. And it was very, very cool. It had a different election protocol even that made it a little more robust than Mongo's main election protocol. But if you're using it, please stop using it because it's not well supported. It's rather old. There's a lot of security vulnerabilities that have built up over the 5 years since 2.0, which it's based off of, has been end-of-lifed. So please be careful. Excuse me. And so I wanted to talk about what were the big histories in Mongo and features around it. So a quick history of Mongo before 3.0 and when 3.2 had, so before 3.0 we had sharding, we had replica sets, and a few other things. We improved the authentication system to where it had roles and responsibility, a proper RBAC type authentication system. And then in 3.2, they made WireTiger more of a default engine. They added a new protocol to improve election speeds, some stuff like that. But there were some other things that they added, like document validation. And this was a very interesting feature because it's providing schema without providing schema. Because it allows a DBA to say, hey, I need this information, but I don't want to make a hard requirement over it. I want to allow a certain role to be able to bypass that. So just be aware that validation was a thing. We also had sharding. So we had parallel queries. We had scaling of nodes, automatic balancing. Is built as a fully HA stack, so there's no single point of failure, stuff like that. It's really quite great. Partial indexes were another thing that were added in the pre-3.4 world, and this is where you might be using a Boolean. And as we all know, if you have a Boolean, your index structures are probably pretty horrible because it's either on or off, and it's going to make the optimizer going to make lots of bad decisions. So what a partial index will do is it allows you to just have certain fields that are matched in a certain grouping order, so that it's very common to have, I don't know, like age and graduation year or something like that together, so that it makes it a valid index that's useful, but it only stores certain things that match certain criteria, so that it's a very small index fitting that very specific use case you might have. The challenge with these, though, however, is the more indexes you have in Mongo, the worse your Mongo gets by just an exponential factor over time. So I don't suggest you have more than 10 indexes maximum per collection, and be very careful about from a server-wide perspective as well, because if you ever are telling Mongo to do an initial sync, copying data is fast. Building 1,000 indexes is not fast because they're going to be built sequentially. But it helps reduce the size of objects to be scanned and things like that. But another challenge is for a given like namespace, so like age and graduation year, for example, I can only have one index with only one set of options. So you have to be very careful with these partials, because you might go, oh, I'll just make multiple indexes for different graduation years or different ranges of different things. It doesn't work that way, and so just you need to be aware of that feature. Also in 3.2, we added lookups or left outer joins. Excuse me. But I think we all kind of know what a left outer join is, to where we just have some data we want to pull in to get a little bit more out of it. It's similar to the DB references that have always been in Mongo, except this allows the server to do it itself, and it's not the client making secondary calls back to the database. Some challenges with that are you still have your 16 meg pipeline limit. So if you just doubled the size of your document, you might be hitting that twice as often. So be aware of it. Mixing storage engines and having storage engines were 3.0 and 3.2. You can mix them in replica sets or different shards or all sorts of different things. So, but in 3.4, we've done considerably more things. So some of what we've done with 3.4 is stuff like improved initial sync. So the initial sync was always kind of challenging, because it could be copying a large amount of data and then building indexes. During that time, you had to have enough oplog for it. So some of the challenges were such as if it had a lot of data, because it had a single thread copying that data, it might never finish in time. Other things are if you had lots of indexes, it might not finish in time. When I was with Object Rocket, I had customers that would take a week to do an initial sync because they had that much data and that much indexes. It's quite terrifying. To the point that once they rebuilt one secondary, if they had to rebuild the other ones, I was rsynching. I was taking a snapshot and rsynching that other one, because I wasn't going to wait another week for when it could be a couple hours for the rsync to occur. But also network issues were a problem as well. because if there was any sort of network blip, it would freeze up and you'd have to start over. There was no resume. 3.4 has thankfully finally fixed a lot of this. That said, please don't use very, very large single nodes. Use sharding, shard with small, cheaper hardware or AWS instances or wherever you happen to be, but get the parallelism. Don't ignore that parallelism, because if you ever need to restore a backup, do you want to restore 5 terabytes or do you want to restore a whole smatter of systems at half a terabyte each? Because that half a terabyte is going to finish 10 times faster than the other way. You're going to be a lot happier on your recovery time. But this does help improve it. It's using multiple streams. It's more aware of recovery and a whole bunch of other stuff. So it is a lot better, but it doesn't fix all the problems. Make sure you're addressing this by a design of actually thinking about how big are my nodes? What kind of recovery window do I really want to accept in a worst case scenario? So collation, which is funny that, Mongo just finally got this in 3.4, because most of us have been used to databases having this for a decade, but it did finally get it. Its main use case is for sorting different language types, because when it comes to different languages, there's different sort orders, or there's even some very custom binary search trees that you can write into sort things with collations if you're doing something really crazy with some binary data that could be useful. But it's really, really useful. But in the end, it was added, and this was one of the oldest bugs in Mongo, was why don't I have collation support? Because there were Japanese users, there were Slavic users, people were just Sanskrit users. They were like, why in the world do I have a UTF-8 database that can't support my natural language? Views are another new feature. I've talked to some of you before on them a little bit. A view is not what you think it might be. You might be going, oh, it's like MySQL. It's a stored query with joins and stuff like that and prepared data, all sorts of awesomeness. No, it is a stored aggregation. So you might want to think about it more like a stored procedure in the end. Specifically, a read-only stored procedure. You cannot write through a view. But the real benefit here to it is I can say my general app user does not have access to certain data, but through a view, they can get access to that very specific data. Or a user doesn't have access to my raw employees table with everybody's salaries, but it could use a view to get a tree of employees and who their manager is to build a nice little dashboard of your company tree. But I don't want that app to be able to leak the CEO's, salary history or some person's quarterly reviews. And so this finally let Mongo have that really nice granular locking, and you could simulate collection level redactions and different things like that as well with it. So it is very powerful, and it was probably the #1 feature I liked about 3.4. Huh? No. So the way it works is when you create a view, it basically, from a usability perspective, it looks like it's a new collection. And so you would just say db.collection.find. It would run the aggregation underneath for you, which is why it's like a stored procedure aggregation and less like a materialized view. Aggregation did have another big feature in it, which is the recursive lookup. So now it can operate more like a GraphDB and find all those recursions and stuff like that. I suggest if you're using this, you use $out as well, because you could have some very interesting problems with the recursion depth and how big the pipeline that you're creating coming out of it is. But it is very useful. The #1 thing that you might notice about it is it can't be sharded. So if you're using sharding, you can't use recursive lookups because that recursion might cross shards. And so that is a whole level of complexity we're not allowing in Mongo yet. Also, there's faceted searches, which is it's an interesting thing. It's like baby Elastic. It's useful, but only to a certain point, because in the end, it's still not a search database. And having this feature is helpful, but I would use it sparingly in very specific cases where you don't have the justification to need a full search system put in place, and you just, normal queries were just, it was a little too complicated, and I wanted to create buckets out of my data for a basic reporting system. It's good there. Some restrictions, however, is it can't use $out, so it can't store to a collection the output. It can't nest, it can't use geo. Obviously, it can't use index stats. What would be the purpose of faceting a report on how often different indexes was used? It's quite bizarre, but I don't know why they added it to the documentation. It seems kind of obvious to me. But it is useful, and the results are stored as an array per aggregation that was nested. And so you might go look at the documentation, because it's rather complicated to explain what it does, but when you look at it, it makes a lot of sense. Also, a decimal type was added. So I don't know if everybody knows this, but for a long time, Mongo decimals were just floats. They weren't real decimals, and so the precision was bad, and that's why it was said it was a bad fit for using in financials. Now with the decimal format and the fact that the default is the right majority, we're much safer with the data that we're talking about, and there's some read preference and some read concerns that you can do with 3.4. So you can say, I want the latest version of this data, or I want the data that everybody can agree on of this data, so people can do some faux transactions to be a little more secure in number management, inventory management, stuff like that. But you do need the new driver to use it, so be aware. You can't just use like the 3.2 driver and it just magically works. It's not going to understand that aggregation pipeline. Nor would it understand this new float type, because it's going to get that, and it's going to be like, I don't know what this BSON element type is. I don't know how to process this. I'm going to segfault. So not the database server, but your client application thread would segfault, because it wouldn't know how to deal with it. Some general improvements, however, are parallel balancing. If you don't know what this is in Mongo, traditionally balancing, I could only move from one chunk, so one 32 meg chunk of different documents, from one shard to another shard at any given time. And any other balancing I need to do had to wait behind that. Now the way it works is half of your nodes could be doing a migration at the most at a time. Because what it says is any single shard may either be a donor or a destination once for a migration at any given time. So if you have 10 shards, you could have 4 migrations occurring at the same exact time in this new 3.4 model. This is a big deal because Mongo was really bad about catching up on migrations. Now, what this would trick you at, if you're not careful, is if I had 4 shards and I added a 5th shard, I am only going to migrate one chunk at a time to that 5th shard, because it can only be a donor or a destination once at any given time. So if you wanted to use this and you wanted to expand your sharding, more smaller shards would get the parallelism, not one single bigger shard added. Also, intra-node communication is now compressed. This is really useful because Mongo was had very big packets and was very chatty with doing replication. With this compression, now your network's going to get a little bit less of a hit, and therefore your replication lag might actually be lower too. This is especially useful across like WAN connections, where having 5 parts of a packet send before it was complete was a considerable amount of time, and now if I can do it in 2, that compression really paid itself off. And then finally, there's log redaction that was added. And this one is really useful because you can say, I do not want any of my queries that could contain PII data to be in my error log, because I need it to not be visible in that for some security request your company has. As a result, you can use a regex to hide this different data with the log redaction system now. yes, your regex is going to get really complicated if you have a lot of different things you're going to try to hide. But you can do it at least, where before you had to do some sort of post-processor to be cleaning up your log files as it was writing them. MongoReplay, I talked a little bit about in the previous. It requires root access because what it does is it creates a TCP dump of all the traffic coming in to a MongoS or a MongoD. It stores that in a file, so then you could take a backup from before you started recording, apply it to some other place, add an index, change an engine, change a version, replay the data, and go, okay, was this faster, was this slower, what was my deviation? And so it's really useful there. Some downsides, it uses TCP dump. So that means if you're using SSL, this tool will not work for you. Because it can't understand those TCP dump packets of an SSL encrypted packet. So there are other things that we could do potentially longer term for it, but it's not critical for this version of the tool right now. This is based, this is an improvement on something else. You can go to GitHub, you can look at something called Flashback from Facebook Parse, and that was an earlier attempt at this same type of thing. But I use this tool all the time for when I have picked the shard key, I duplicate a client's environment, and then I use this to replay data after I've picked the new shard key to be able to say how the new system would behave with that new shard key. And the reason for this is I want to know if the scatter gathers are more expensive than I anticipated. Did we pick a bad shard key and the query times are going to be worse than they were before? Stuff like that, just because I'm the type of person I want to load test everything before it goes into production. Not all of us has this luxury, but at least now we have a tool if we have the luxury of being able to do that type of load testing. And that way we can do real testing rather than synthetic testing. Some real high level of enterprise server. It has LDAP, which is external authentication, has an audit trail, an encrypted storage engine, an in-memory engine, BI connectors, Mongo Compass, and some ops manager stuff. Whereas Percona server has the LDAP stuff still. It has the audit trail still. We've added binary hot backups, so you don't have to take your server offline to do a backup. If you want binary data, you don't have to lock it, you don't have to block it. Your system can continue working as it's going. We've also added MongoRocks engine, in-memory engine. Our Percona monitoring and management has more metrics than Ops Manager, but it doesn't have some of the provisioning that Ops Manager can have or the backups integrated into it yet. Those are later stages for this tool. We'll have some demos of PMM Server. We have some talks on PMM Server as well. It's really a great product. It's using Prometheus and Grafana to store metrics from your system. I'm storing pretty much everything you can imagine from Mongo. In fact, I actually wrote some extra stuff too that you might not know about, like some lag detection stuff that's not normally in server status. But also I wrote some stuff to tell me if my nodes are having delays being able to communicate to each other as a precursor to I might have election problems because I'm about to start having longer communications and my heartbeats are going to start failing. I wanted to be able to say, oh, my heartbeats were failing and then I had an election. I didn't want to go, why did this election happen? I wanted the graphs to help explain that to the community. And then we've also improved some profiling for you so that you don't have to profile everything. It'll profile a random sampling of everything as well as slow things to give you some more information about the different ranges of a good query versus a bad query of any given shape. And finally, we also added 2 tools to the Percona toolkit for Mongo, and that is PT MongoDB Summary, which is a good overview of your system. What type of, is it x86? Is it 64-bit? Is it 32-bit? Is it, what kernel is it running? Stuff like that for us. It can detect whether or not it's in a cluster and give you all the members of a cluster, or in a REPL set, give you all the members of that. It can give you information about arbiters, stuff like that, slave lag, number of users defined, number of databases, collections, indexes. Is my cluster balanced? All sorts of different things like that. This was really created because I wanted a good diagnostic tool that if you were raising a support ticket, you were asking something in the forum, you could run that tool and I would have a good idea about your environment, but it was a simplistic output as well. So you could redact anything that you didn't want to show me or didn't want to show somebody on Stack Overflow. But people could get a good idea of what's going on in the system. I have all these members, which members are which engines, how are they joined in the replica sets, what is my infrastructure, stuff like that. And the other one was PT MongoDB Query Digest. This is a profiler tool that works just like the MySQL one to give you and help explain what your expensive operations in your system are. And so that is the high level of 3.4. There's lots of other features, but the big ones really are the parallel balancing and the views and stuff like that. Those and collations. Those are the really big things. This was very much more what I would consider a maintenance release rather than a major release for Mongo because they were fixing a lot of long-standing problems. But if you have any questions, I'm more than glad to talk about those. 3.5 is shaping up to be a much more major version. And so later this year, you'll hear a lot more about that. All right, anybody have any questions? All right, well then, y'all have a good rest of the afternoon and evening.